What is with these warm-up questions? Here is an application of, equations of lines in 3-space, in this case, equations of lines using vectors rather than your old school grade 8, probably 8, 9, 10, 11, and advanced functions 2-space and without vectors. So the question reads, determine whether the points A, -9, -3, -16, and B, 6, 5, 13 lie on the line that passes through the point 0, 0, 2 and has direction vector with components 3, 1, and 6. A reminder to you that at any time you can pause a video. I'm sure you know that. And at any time you can go to the Google site and get yourself the blank notes to work from. That may be especially important when we go to draw some pictures, which are ugly in 3-space. All right, so my go-to for each question, especially since I'm given a point and a direction vector, and I'm talking about a line, is to make myself a vector equation. Now, that doesn't mean I'm going to stop after a vector equation. That just means I have the info to make one. So vector r, or xyz, 3-space, is equal to the point 0, 0, 2 plus t 3, 1, 6. And I remind you that the type of bracket is not something that I am going to be looking at super closely. What is important is that your direction vector sits with your parameter and your point does not sit with your parameter. All right, so I've got, and I'm going to do this color coordinated, I've got A, which is this, and I've got an x coordinate, a y coordinate, and a z coordinate. And I'm going to take this vector equation and I'm going to turn it into the parametric equations. So x is equal to 0 plus 3t, y is equal to 0 plus 1t, z is equal to 0, 2 plus 6t. And with red pen, I'm going to take the -9, the -3, and the -16 and substitute them in for x, for y, and for z individually. So -9 is equal to 3t. I can solve that. That is something where I can get the t by itself. And I end up with t is equal to -3. So now I have an expected t value for the other two. So the next one is -3 is equal to t, subbing -3 in for the y. And that's the same thing, so I'm happy. Now, the last one, -16 equals 2 plus 6t. So I'm going to subtract 2 here. So that's -18 equals 6t. Divide both sides by 6. And I end up with the exact same t value. T is equal to -3. And that means, therefore, A, -9, -3, -16 is on the line. I'm going to assume, but prove in a second, whether that B is on the line. I'm thinking it's not. I'm thinking I probably would have planned it otherwise. So I'm going to change this to blue, and I'm going to do this set of solution with blue with the same thing. So I'm going to take 6 and plug it in here. So 6 is equal to 3t. And if I solve for t, I'll divide both sides by 3, and I'll get t equals 2. So that's my expected t value. So then I go on and I sub 5 in for y. So that is 5 is equal to t. Nope. As soon as you do that, you do not have to worry about the Z. It already doesn't match. It has to be a triple match. So as soon as you don't have something working out, that means that you can say that B, which is 6, 5, and 13, is not on the line. So there you have it. My expectation was right. So now what we're going to do is we're going to go on and we're going to look at intersection of lines. Now, intersection of lines, once upon a time in grade 10, required you to do elimination and substitution. But that was in 2 space, and now we have 3 space. So I'm going to show you the question, and then I'm going to flip to the next sheet, which is a list of steps to follow. So intersection of lines, here is your example. Line 1 has this vector equation, and line 2 has this vector equation. Notice that because there are 2 separate lines, indicated by L1 and L2, you have to have 2 separate parameters. So I've decided with this question that my parameter for line 1 is T and my parameter for line 2 is K. And my important notes follow on the upcoming pages. So here are your lines. It's 3 space. And our job is to determine the intersection, if there's any, of these 2 lines. So hopefully you remember something from grade 10, and that is that these lines are either going to cross or they're not going to cross. And they cannot cross in multiple different ways, but they can cross only in colliding with each other in a point. So here are the steps. Pause if you must. So your first thing is, pretty please, save yourself some time and take a look at the direction vectors and notice whether they are scalar multiples of each other, meaning that one is the other one times by a number. If they are not scalar multiples of each other, that means you should carry on. It means that the lines are not parallel. So if I go back to our lines and I look at the direction vectors, they are not scalar multiples of each other. If they were, that means that the lines would be parallel, in which case they wouldn't bump into each other from what we know. Once you determine whether the direction vectors are not scalar multiples of each other, then you take one line, doesn't matter which one it is, turn your equation into symmetric equations, and make sure the other one is parametric equations. So if I give you 2 in vector equations, one of these you turn symmetric and one of these you turn parametric. And it doesn't matter which is which, it just means that there's 2 separate solutions with the same answer. So the first thing I'm going to do is I'm going to take line number 1, because it's the first instruction and it's my choice, and turn the vector equation into the symmetric. And then I'm going to take line number 2, which is still in vector equation form, and I'm going to turn it into its parametric form. So that'll be 3 parametric equations. So we'll start with that, and again, I will color code. So, line 1. Let's see if I can do this quickly. So I'll have x subtract 5 from the other side divided by the 3 that will isolate the t equals y subtract 2 from the other side divided by the 2 that would be beside the t in the parametric equations equals z add 7 divided by the 6 that would be beside the t in the parametric equation. Now I'm going to take line 2 and turn it into its parametric equation. So x equals 4 plus 2k. Y is equal to negative 6 plus 5k. Z is equal to negative 3 plus 1k. So that is step 2. Step 1 being check for scalar multiples. The next thing is you get to substitute the parametric equations into the symmetric equation. So that means I am going to take the x, y, and z that's sitting here, and I'm going to substitute them in here. And that's going to take a little bit of work. I'm going to change colors, again, just for fun. So x is 4 plus 2k. So x will be 4 plus 2k. Also subtract 5 and also divide by 3. Equals y is negative 6 plus 5k. Also subtract 2 and divided by 2. Equals z is negative 3 plus k. Also add 7 and divided by 6. And before I go on, I can see some like terms, so I'm going to collect like terms in each of the fractions. So this one, 2k minus 1 over 3. This one, 5k minus 8 over 2. This one, k plus 4 over 6. Let's go looking for the next step. Solve for the parameter in 2, or if you've got extra energy, 3 of these proportions, and hope for a single value. So what I'm going to do is I'm going to take these two, because they're right smack dab beside each other, and I'm going to cross multiply, and I'm going to try to get k by itself. And then I'm going to take these two and do it again. I technically don't have to do the other ones. It's just really if you have extra energy. So it'll be for these two right here, it'll be 2 times 2k minus 1 equals 3 times 5k minus 8. And yes, of course, you can do that in your head if you can pull it off without making any mistakes. K's on one side, non-k's on the other side. We'll get negative 11k is equal to negative 22. So I end up dividing both sides by negative 11 and getting k is equal to 2. So according to my instruction, I am hoping for a single value for my parameter. That means when I go to do part 2, I am hoping for k is equal to 2. So again, I'm going to be careful. 6 multiplied by 5k minus 8 equals 2 multiplied by k plus 4. So what I've done in both cases is this equals this. And then what I'm doing now, this equals this. And now I'm going to do straight algebra. Sorry for the silence. Concentrating. 48, 49, 56. Divide both sides by 28, and I get k is equal to 2. And when these two match, I'm going to put a happy face, even though that means extra work. When you get that single value, that actually means you're going to have a point of intersection. These lines are going to collide with each other in a point. So the way you find that point is you sub the single value, in this case k is equal to 2, into the set of parametric equations that used k. So make sure you don't use it for t accidentally, and you determine the actual point of intersection. So that is this set. group clone ungroup. So x is equal to 4 plus 2 times 2 is k. So it's 4 plus 4, which is 8. This one, negative 6 plus 5, k is 2. And this one's pretty easy. So that means these two lines meet at the point, round bracket, 8, 4, negative 1. All right, so let's try it again, and let's think about this. This is not going to be the same result because that wouldn't make any sense. Let's do the exact same thing. So, line 1, symmetric equations. So, x minus the 2 divided by the 4 gets t by itself equals y plus the 5 divided by the negative 6 gets t by itself. Z plus the 3 divided by the 11 gets t by itself. So this is equal to t, this fraction is equal to t, this fraction is equal to t, and that means that you can say they're equal to each other. So in case that was too quick, because I did do it before, this is what I did, for example, with x, and I'll erase it in a second. Took 2 across the equal sign mentally, divided both sides by 4, all in one step. And I did that 3 times, once for the x, once for the y, and once for the z. So now I'm going to dig out my blue pen and worry about line 2. So x equals 0, subtract 7k. So symmetric with one of them, doesn't matter which. Parametric with the other one. Y is equal to 4 minus 3k. And when I say 3k, I should write 3k. Z is equal to negative 9 plus 5k. Then I get to take each of these things and sub them in for the x, y, and z to set up for cross multiplying. So x, negative 7k subtract 2 over 4. That one's easy. Y, 4 minus 3k plus 5 over negative 6. Z, negative 9 plus 5k plus 3 over 11. And I'm going to tidy this up. Of course, you can start cross multiplying before you tidy it up. And I'm going to actually, nope, I'm not going to. I was going to back it up and not tidy it up. So 1 minus 3k over negative 6 and 5k minus 6 over 11. All right, so one thing I forgot that I should never forget is to check that the direction vectors aren't scalar multiples of each other. Because if they're scalar multiples of each other, that means they're parallel. If they're parallel, it might mean that they're never going to meet like railroad tracks. But if they're parallel, it might also mean that they are exactly the same line. And you have to determine by taking one of the points and subbing it into the other x, y, z to see if it's the same line or if it's not by solving for k. So same deal. If you need an example of that, please speak with me. I would be happy to give it to you. Probably the next warm-up question. I can't promise. I haven't looked ahead. So, let's see. Oh, notice that the direction vectors are not scalar multiples. This means these lines are non-parallel. That means you keep going. Yes, you should check this every time. So now we carry on. So I'm not going to show as much work this time. So I'm not going to show my actual cross multiplying. I'm just going to do the math, meaning -6 times -7k is 42k. -6 times -2 is +12 equals 4 times 1, 4 times -3k. So I'm doing that. 42k plus 12k from the other side is equal to 4 minus 12. That's 54k. Yikes, this is ugly. Equals -8. Divide by 54. Divide by 54. K is equal to divide by 2, divide by 2. So I really should reduce all my fractions. And yes, your letters are allowed to be fractions. So the next thing is we double check that this k is the same, which it was in the last one. So my prediction is it's not the same here because I wouldn't do the same kind of example twice. But let's see. 11 times 1, 11 times -3k, -6 times 5k, -6 times -6. So -33k plus 30k is equal to 36 minus 11. So -3k is equal to 25. Not that it matters, because this is not going to turn out to be -4/27. Did it again. That means therefore these lines do not meet. Now, here's the thing. In two-space, in grade 10, with elimination and substitution, and I can draw this for you because I'm very good at drawing two-space. So in two-space, where you had an x and a y-axis, you had three possibilities of arrangements of lines. You either had two lines meeting in a point of intersection, or you had two lines that were parallel, in which case they didn't meet at all. So we said in grade 10, this is 1 point, this is no point, let's say points, there is a point. And the other possibility in grade 10 was that the lines ended up right on top of each other, in which case there were infinitely many points. But this is three-space. So our first example was three-dimensional space where we the lines bumped into each other, and they bumped into each other in a three-dimensional point. So in 3D, a point, 8, 4, -1. In 3 space, you actually have 3 possibilities. You'd have these 3 possibilities and a fourth. So yes, you can land in one point, bump into each other in one point of intersection. You can intersect in no points because the lines are parallel and will never bump into each other. They can be the exact same lines, in which case you have infinitely many points. But there's also something I can't draw, and what I can't draw are skew lines. And the best way that I can describe skew lines in a way that might help you visualize them is you've got 2 planes flying in the sky, and you're looking on the ground and their flight paths cross because the sky is 3-dimensional. So their flight paths cross. The white lines that you see from the planes, they bump into each other. But if you were in the sky and you were in one of those planes, they don't cross because they're at different levels. So it means the planes aren't flying parallel and they're not going to bump into each other. It's because you have a 3rd dimension that they would cross if they were at the same altitude, but they're at different altitudes, so they don't bump into each other, and that's what a skew line is, or a set of skew lines. So I've got that written down here, not my analogy, but skew lines are in R3, they're non-parallel, and they're non-intersecting. So here is the work. You'll probably get the 4 different possibilities. You'll get skew lines, you'll get parallel, not the same lines, you'll get the same lines, and you'll get a point of intersection. Now, I know that I've used point of intersection and point of inflection as the same acronym, but if you think about it, you don't use them in the same spots. Point of inflections happen when you're drawing curves. Point of inflections happen when you're drawing a curve. Point of intersection happens when you're drawing multiple lines. So that is it for intersection of lines. We're going to come back with planes, and I don't mean airplanes.